Hello, everyone. I wanted to do a few more examples with you on finding inverse functions. We had to kind of rush through this part in class a bit. So I wanted to do a few more problems for you just in case you needed it. So to refresh your memory, an inverse function is basically a function that reverses or undoes another function by switching x and y. That's the big important thing that I need you to get. An inverse function switches x and y. So if on your forward, for lack of a better word, function f, you put an x in, you get a y out. On your inverse function, your x and your y switch places, and that y value would go into your inverse function and the x value would come out, right? They undo each other. And since your x's and your y switch on your inverse function, your domain of your inverse is going to be the range of your original function, right? Because the domain of f inverse, the things that are going into your inverse function, are the things that came out of your original function. That's your range, right? So the x's on your inverse are the y's of your original, and the range, the outputs of your inverse, are going to be the inputs of your original function f. The biggest thing that we are going to use this for is that the domain of your inverse function has to match the range of your forward function. We are going to use this to find domain. And yeah, that's what we're going to use to find the domain of your inverse function. Okay, so we were able to do number 1 in class, but I wanted to do 2, 3, and 4 with you just so you had some extra examples. So let's do number 2. What we're asked to do here is find our inverse function and then find the domain of that inverse function. Okay, so to find our inverse, we're going to do what inverses do, and we are going to switch x and y. So before we can switch x and y in this problem, I have to figure out f of x equals x minus 3 to the third power. I don't see y anywhere. So what I'm going to do is f of x, that is y. It's right here, right? So I'm going to replace f of x with y so that my brain can see where y is. Okay, and now we're going to do what inverse functions do, which is switch x and y. It's a Freaky Friday situation. Anywhere you see an x, you're going to put a y. Anywhere you see a y, you're going to put an x, and you are going to switch places here, right? X and y, switch places. Once you switch x and y, we are now in inverse land. This is our inverse function. But most of the time when we write functions, we write y equals, right? All of these functions that we have here are y equals. That's how we usually write functions. So I want to get y equals on my inverse function. So that means we have to solve for y here. So if I want to get this y by itself, what do I have to do first? Well, I have to get rid of this exponent of 3. How do I do that? I'm going to take the cube root of both sides. Yep, so I'm going to take the cube root of both sides because a cube root undoes an exponent of 3. And so then what I'm going to have there is the cube root of x over here, and this cube root undoes that 3, so I'm going to have y minus 3 left over here. Now to get to y, you're going to add that 3 to both sides, and I'm going to have that y is equal to the cube root of x plus 3, and that is, in fact, your inverse function. So if you want to label that as f inverse, you can do that. This is what your inverse function looks like. Okay, so we just found f inverse. And so now we have to find the domain. So we could apply domain rules to this, but there are certain cases where you're applying your domain rules won't quite match the range of your original. Again, we need to make sure that the domain of my inverse matches the range of my original. Now, we only found range from graphs. That's the only kind of range that we've talked about. We haven't really found range of an algebraic function. It's not the easiest thing in the world to do. You have to think about what kind of y values come out no matter what x values in the domain you put in. And sorry, my dog is freaking out. Sorry about that. That's not the easiest thing to do. And so what we need to do is graph this thing, and we'll get the range from a graph. So now I have to figure out what the graph of this thing looks like. Well, this is a transformed x cubed graph. X cubed is one of our back pocket functions. X cubed looks like a whoop-de-doo, right? This is y equals x cubed. And what this minus 3 is going to do here, this minus 3 is going to shift us to the right by 3 units. So it's going to shift us 1, 2, 3 units to the right. This is what my forward function looks like. Okay. Sorry, guys, there's someone walking by my house, and so my dog wants to bark at them. He's keeping us very safe, but hopefully that will subside soon. Okay, so this function is shifted to the right by 3 units. This black one is what this function looks like. What's the range of that function? What y values are covered? Well, this covers every y value from negative infinity all the way up to all the y values up to infinity. The range of this thing is negative infinity to infinity. So that is the domain of this function. Notice that matches what we would have gotten if we applied our domain rules to this function. The only domain rules that apply to this is the root rule. Root rule says if the index of my root is odd, then my domain is everything from negative infinity to infinity. So this actually matches our domain rules, which is fantastic, but that won't always be the case. So we're going to try to get that from a graph if we can. Okay, let's try another one. Our original function f of x is the square root of 3 minus x plus 10. Okay, so again, to find our inverse function, we need to switch x and y because that's what an inverse function does. My brain wants to see where y is. F of x is y, so I'm going to put the y right there to say that's where the y is. And now to find our inverse, we are going to switch x and y. Y's become x's, x's become y's. Now we are in inverse land. But in order to write an inverse function, I want y equals, which means I have to solve for this y right here. To get that y by itself, first thing that we need to do is subtract 10 from both sides. So I'm going to subtract 10 from both sides, and I'm going to get that x minus 10 is equal to 3 minus y. And again, my goal here is to get this y by itself. I can't get the y by itself right now because it's stuck inside a square root. So I have to get rid of that square root. To do that, you're going to square both sides. So we are going to take this side and square it. And we also have to take this whole side and square it. Okay, so what we have now is x minus 10 squared is equal to 3 minus y. And then now what we can do is subtract that 3 from both sides. So I'm going to get x minus 10 squared minus 3 is equal to negative y. And then to get y by itself, I'm going to have to multiply everything by a negative 1. Before I do that, I'm going to multiply this out so that I can combine my like terms here. When I take x minus 10 times x minus 10, I'm going to get x squared minus 10x minus another 10x plus 100 I still have that minus 3 equals negative y. And I can combine all of my like terms. I've got negative 10x and negative 10x. Those will combine. And I've got the 100 and the minus 3. Those will combine as well. And so I will have x squared minus 20x plus 97 equals negative y. Now I can multiply everything on both sides by negative 1 to get y by itself. And then I will get negative x squared plus 20x minus 97 is equal to y. That is my inverse function. Okay, so that's my inverse function. We have to find the domain of that. Okay, well, if I applied my domain rules to that, I don't have any roots, I don't have any fractions, I don't have any logs. Because no log rules apply to this, our domain would be negative infinity to infinity. But remember, we need the domain of our inverse to match the range of my original. So before I find the domain, I need to figure out what this looks like so that I can find the range. Okay, so this is going to be a square root of x graph. Okay. Square root of x looks like this. That's our basic back pocket function. And we are going to have some transformations here. The transformations that we're going to have, this negative, sorry, I always do that. This negative here is going to reflect us left and right over the y-axis. So it's going to flip us sideways. This, sorry, I've got to try to keep that color. And then this, adding 3 inside here, this is going to shift us to the left 3 units, because technically I'm taking a negative 1 times x and I'm adding 3 inside. I know there's subtraction between the 3 and the x, but the 3 itself is not being subtracted. It's actually being added because it's positive. So that's going to shift us left 3 units. And the last thing that I have here is going to be this plus 10. That's going to shift me up 10 units. And remember, when we are doing graph transformation, order matters. So the first thing that we're going to do is move our graph left and right. So you do horizontal shifts first. So the first thing that we're going to do to this base back pocket function is slide it left 3 units. So I'm going to go 1, 2, 3 units to the left, and I'm going to shift that whole thing over here. And then after you move left and right, the second thing that you want to do is any reflections or vertical or any stretches or shrinking. We don't have any stretching or shrinking here, so we just want to reflect this thing left and right. So I'm going to take that green one and I'm going to reflect it left and right over this y-axis. So if this was a mirror, then what this green one would look like in the mirror is I would come over here to positive 3 and it would open up in the other direction and it would look like that. This is the mirror image of that green one. So this is what I would look like after I reflected over the y-axis. And then the last thing that I have to do here is move this graph up and down. So now I'm going to take that red one and I'm going to move it up 10 units. So I'm going to come up to wherever 10 units is. This is where I'm going to start now, and I'm still going to have the same shape going that way. Graph transformations. Okay, so that is what my final graph looks like. It's that light blue one. What's the range of that light blue one? What y values are covered by that blue one? Well, that light blue one doesn't cover any y values below 10, right? The first y value that's covered is 10, and this thing is going to cover everything higher than 10. So my range here is -10 to infinity. This is the range of my original. That means this is the domain of my inverse function. The cases where you have a square root in your original function, that is going to change your domain, and you can't apply your domain rules to your final one, because that's going to get overridden by the domain or by the range of your original. So whenever you have this square root in your original, that's where you're going to have to graph this and check the range. Most of these others, you won't have any trouble with those, but just go ahead and get in the habit of drawing your graph and checking that the range of your original is the domain of your inverse. The one exception to that, now that I've told you to do that, there is one exception, and that is rational functions. When you have fractions with variables in them, graphing these guys is going to be a bit of a headache. It's going to be an involved process. And we are going to get to that in our next class. But I don't want you to bother to have to graph this to get your range. To find the domain of your inverse. What I'm going to tell you is that for the rational functions, just use the domain rules on your inverse function at the end. Only with rational functions, I don't want you to worry about the graph to get the range. Nothing weird is going to happen on rational functions. It's mostly going to be square roots that you have to worry about that. So with rational functions, just apply your domain rules, and it'll be fraction rules that you're applying to your inverse function at the end. Okay, so that being said, before we do the range of our, or before we do the domain of my inverse, I have to find my inverse function. So I'm going to call this y, and then I'm going to switch x and y to find my inverse function. Y becomes x, and x becomes y. Everywhere I see it. So I have an x here and an x here. Both of them become y's. Okay, so now that I've switched x and y, I need to solve for y because I am in inverse land right now, but to find my inverse function, I need to be able to write y equals. Now, the hard thing here is that to get y equals, I've got two y's. So how do I do this? Well, right now I have a y stuck on the top of this fraction and a y stuck on the bottom. So the first thing that I need to do is get rid of the fraction situation that I have going on here. The way that you do that is by multiplying this denominator, this 1 plus 8y, on both sides of your fraction. That is going to clear your fractions. It's going to make it so that I don't have y's on the top and the bottom of a fraction. It'll make it so that I can separate them and try to get all of my y's on one side. So now that I have that, what I need to do is I'm going to distribute this x into here, and notice that when I multiply on this side, these guys cancel. So on the left, I'm going to multiply this out, and I'm going to get x plus 8 times xy. You can write yx. My brain, I've always just been programmed to put them in alphabetical order. It's, yeah, something that was drilled into me as a kid, and I can't get rid of it. So, but you can write 8yx. There's no problem with that at all. And on the other side, I have -9y plus 7. Okay, so this is now what I have. What am I trying to do again? With all this algebra, I'm getting myself lost. I'm on my inverse function. I'm trying to get y equals because that's how we write functions. So I need to get y by itself. But I have y's on both sides of my equation. But now the y's are kind of free to move. They're not stuck inside a fraction. They're not stuck inside parentheses. They're free to move around. So I want you to put anything with a y on one side of your equation anything without a y on the other. I'm going to put all my y's on the left side of my equation. So I'm going to add this 9y to both sides to put that 9y on the left side. And then anything without a y, I want to put on the right side of my equation. So this x over here does not have a y, so I'm going to subtract it from both sides to move it to the right-hand side because it doesn't have a y in it. So now that I have that, these guys are going to go away. These guys are going to go away. I'm going to get 8xy plus 9y equals 7 minus x. And now everything over here has a y in it, which lets me factor it out of this side. And when I do that, I get 8x plus 9 equals 7 minus x. And now to get y by itself, all I have to do is divide by that lovely 8x plus 9. And now I have y equals this beautiful fraction, which is my f inverse function. That is my inverse function. And to find my domain of this, again, rational functions are a pain to graph, so we're not going to bother graphing these guys. We're going to apply our domain rules. The domain rules that apply to f inverse are our fraction rule. The fraction rule says pay no attention to what's on top of that fraction. Make sure that the stuff on the bottom, which is 8x plus 9, make sure that's not equal to 0. And so if I solve for this, I'm going to subtract 9 from both sides, which says that 8x cannot be equal to negative 9, which says that x cannot be equal to negative 9/8, but it can be anything else. And so my domain here is going to be negative infinity to negative 9/8, union anything from negative 9/8 to infinity. And if you have a hard time getting to there, you can always put this on a number line and say, well, negative 9/8 is somewhere on here. I cannot be equal to negative 9/8, but I can be anything else. Everything over here is that negative infinity to negative 9/8. Everything over here is that negative 9/8 to infinity. That is the domain of this inverse. All right, so hopefully that helps with this module 2 with your inverse functions. So just kind of fight through some algebra here and make sure that with anything except for a rational function, except for fractions with variables in them, I want you to graph your original function to find the range. That will tell you what the domain of your inverse function is. Most of the time they will match, but not when you have square roots in your original, just like number 3 here. And if you have a rational function like number 4, don't bother graphing it because it's going to be a pain, as you will see in our next class meeting. Instead, I want you to just apply your domain rules to the end. All right. I hope that helps. I hope you have a lovely day, and I will see you next time.